Hi ladies, it's Mr. O'Sullivan. Today is Friday, January 5th. Again, very sorry, but I will not be in today, but I promise I will be back on Monday. So today we're going to be looking at lesson 4-2, geometric sequences, and today's learning target is I can apply my knowledge of exponential functions by extending them to geometric sequences. So we did this again in Algebra 1. This is going to be a very quick lesson. It's only 2 examples. Pause the video to make sure all of this is filled in. That way you have all of this on your note sheet. But let me start going over it. So geometric sequences are sort of like exponential functions. This should say geometric. What is it called? Geometric sequences are exponential functions. So they're sequences that are created by multiplying or dividing by the same value each time. So the rule for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1, where a sub n represents our nth term. Think of that as like a y value. A sub 1 is the first term of your sequence. N is just your term number, and then r stands for your common ratio. That's sort of like your common difference. And if you're ever stuck and you're like, I'm not sure how to find my common ratio for a sequence, just do a sub 2 divided by a sub 1. Or term 2 divided by term 1. And that will tell you your common ratio. Now, when it's in its fully simplest form, a geometric sequence will always be an exponential function. So let's see how we can figure it out. So yesterday we learned about arithmetic sequences. So we would first figure out like, okay, so to go from a 3 to a 9, I add 6, and then 9 to 27, I add 18, and then 27 to 81, I add 54. So since I'm adding by a different value each time, it can't be arithmetic. So then I have to sort of like think outside the box. So we just mentioned multiplication. So to go from a 3 to a 9, I multiply by 3. 9 times 3 is 27, and then 27 times 3 is 81. So I now know it's geometric because I'm multiplying by that value of 3 each time. So yes, it's geometric. And the common ratio, or the number you're multiplying by each time, is 3. So now if it's geometric, we now want to write our explicit formula. So this is actually much easier than an arithmetic sequence. We're just going to rewrite it real quick. So a sub n equals a sub 1 times r to the n minus 1. So if I want to do this, my first term is 3. So I can say a sub n is equal to 3. I'm multiplying by 3 each time. And then I just put n minus 1. And that would be my explicit rule. That's your final answer. That's it. Now, if you want to say find like the 6th term of this sequence, like the 6th term or the 7th, I would just plug in 7 like this. And then when I type that into my calculator, I get, give me 1 second, I get 2,187. So like that could be like an extension question on Delta Math, like find the 7th term, the 10th term, etc. So you just plug it in, just like you did yesterday with the arithmetic sequence. Now in this sequence, it's 100, 50, 25, 12.5. So my numbers are going down. Not sure what they're going down by, but they are going down. So I'm not sure what it's going to be. So I'm just going to take my second term and divide it by my first term. So I'm going to do 50 divided by 100. And if I type that into my calculator, it's 1/2. So basically, if you think about it, 100 times a half is 50, 50 times a half is 25, and then 25 times a half is 12.5. So this is geometric because I'm multiplying by 1/2 every single time. So it is geometric, and my common ratio, the value I'm multiplying by each time, is 1/2. So now for part C, if I want to write my explicit formula, I just do this. A sub n equals a sub 1 times r to the n minus 1. And now I do my substitutions. My first term is 100. My common ratio is 1/2. And then I have my n minus 1. And that would be our final answer. So that is what you need to know about geometric sequences. Now, please complete your Delta Math assignment on geometric sequences. Have a great day, ladies.